So what we did last week is we looked at the A, the B, the C, and the D, and what they did individually. And we are going to use what they did individually to develop a shortcut for graphing sine and cosine. So just to recap, you remember that your A, which is a vertical stretch, we noticed that that always changed the amplitude. The B value, the horizontal stretch or compression, always affected the period. And we know that for sine and cosine, the period is normally 2 pi. So we created a formula that the period would be 2 pi over b. And of course, for tangent, it was pi for the period. And so for tangent, it was pi over b. C did exactly the same as before, move things left and right. And D moved things up and down, but in particular, sine and cosine have a sinusoidal axis. And that D value moved that sinusoidal axis up and down. And so normally, if we are doing transformations, we have to do stretches and compressions first, and translations last. And that's still the case. You can still do that way. But as a shortcut, since your center line starts at 0, multiplying it by something won't affect it. So we can actually start with the D value, and the very first thing we do is find out where our sinusoidal axis is. That's helpful because your amplitude is always the distance from your center line, from your sinusoidal axis, to a maximum or minimum. So then you can go to your A value and use the amplitude to find what your max and min values for your sine or cos graph will be. Next, we go to our B value. And we use that B value to calculate the period. Of course, we had that formula the other day that your period was 2 pi over your B value. You can label your period on your x-axis, and just like normally with the sine or cosine graph, we have our axes family in 4 sections. You take your new period and divide your graph into 4 sections. Now I call the technique that we're going to use for graphing the shortcut, we wrote it at the top, I call it DAB-C, because it's easy to say. And the dash in the DAB-C actually represents something as well. The dash says, after you've done the DAB part, draw your graph without the phase shift, just with a dotted line. So the dash says, draw something with a dotted line. And then finally, we find out what our phase shift is, left or right, draw those ticky marks, and since you have your dotted line already, it's going to be easy to shift that dotted line either left or right. So this is going to be our shortcut for graphing sinusoidals. And I call it DAB-C because it's easy to remember. That's the order that we can do the shortcut in. And now we're going to look at what happens when we do this with some graphs. So here is our first example. And I wrote DAVC because I'm going to show you slowly what it looks like. You may go back up a bit. That's fine. Sorry. I'm going to show you slowly what it looks like to go through this in the right order. And each time we finish a letter in DAVC, and even the dash, we will put a little check mark saying, this is all this means. Some of them are really quick, some of them are a little bit more involved. So, I want to graph this. It has all the transformations. I notice that it is nicely already in factored form, so that's good. It is in the right form. This would be my A value, my B value, my C value, my D value. So we're going to graph. We set up our graph. Get our grid paper ready, and the very first thing that we're going to do is start with our D value. Our D value is 1. So what we do is at y equals 1, we draw a horizontal line, dotted line, because it's not part of the graph. It just helps us draw the graph. And this is all you have to do for the D part. So all we use the D value for is to draw our average. Next, we look at our A value. Our A value is 3. That's our amplitude. Amplitude is the distance from your center line to a maximum or to a minimum. So we now know, since the amplitude is 3, we're going to have to go up 3 and have a maximum of 4. And we're going to have to go down 3 and have a minimum of -2. So the amplitude is just there so that you can draw your maximum and minimum. So I now have my maximum and minimum labeled. Next, our B value helps us find our period. We have the formula that period is 2 pi divided by our B value. So I know that the period is pi, so I go somewhere on my x-axis and label 1 period pi. Doesn't matter where that is, but we're going to need to divide this into 4 equal sections, so I cut it in half, cut each of those sections in half. So we label 1 period and divide that period into 4 equal sections. So this would be pi over 2. This would be half of that, pi over 4, and this 1, 2, 3 pi over 4. So the B value lets you find your period. You have to find your period and divide it into 4 equal sections. So we've now done the DAB part. Next, we graph our graph with a dotted line. This will not be our final graph. We're going to do no shift, but we just say, where does a coast graph normally start? Coast graph normally starts at a maximum. So I go to my maximum, which is at 4, and then at the next ticking mark, I'll be at my center line. The next section, pi over 2, I'd be at minimum. Then 3 pi over 4, back to the center line, and finally, 1 full period, I'll be back to the maximum again. And I draw the graph with a dotted line, because this would be the graph with that D value, with that amplitude, with that period, with no phase shift whatsoever. That's what the dash says. And finally, to draw our final graph, and I'll draw our final graph in purple, it says we have a shift of pi over 4 to the right. Pi over 4 is already nicely labeled on our graph, which is kind of helpful. Okay, we're going to need to shift everything over pi over 4 to the right. So this maximum will get shifted pi over 4 to the right. This point at pi over 4 will get shifted to pi over 2. Pi over 2 will get shifted to 3 pi over 4. 3 pi over 4 shifted to pi, and I guess I should make one more ticky mark. So I took the 5 points, I figured out what my phase shift was, and I moved each of them that distance over to the right.
Sorry for the interruption. Ms. Carpa to the office, please. Ms. Carpa to the office.
And there we have the complete graph. And the nice thing is, you didn't have to, like, if we did this the same way that we did in transformations, you would have to take your 5 original points from your coast graph. Do your stretches and compressions first, do your translation second, and then label 5 new points. This method lets you go directly to the graph right away. It lets you figure out what your center line is first, which lets you go there, use your amplitude to find your maximum and minimum. Use your B value to find your period, divide it into 4 equal sections, and then we graph it temporarily without the phase shift, just so we have an idea where the main points are, and then we shift it in the end afterwards. So we're going to do another example right away to practice this. These are very typical questions that come up on the final exam, and they're usually worth 4 marks each. Now sometimes you can do a little bit of pre-planning. Right? The little bit of pre-planning that I did here is I sort of looked at what my D value and my A value would be to figure out where I kind of want to put my axes. Because again, I'll write dab C off to the side. I know that my D value is going to be at -2. Check mark. That's all you have to do for your D value. Your amplitude is 4. Even though it's a -4 out front, amplitude is always a positive number. And your amplitude tells you how much you go up and down from your center line. So my maximum, if I go up 4, I will have a maximum at +2. And if I go down 4, I will have a minimum at -6. So when I did a little bit of pre-planning, I was like, I look at my D and my A value to start off with before I draw my grid so that I leave myself enough space. In this case, I knew I'd have to go more into the negatives than I'd had to go into the positives because my D value was at -2. So our A is done. We got our D value to draw our center line. All we use our amplitude for is to get our maximum and our minimum on our graph. Next, we have to figure out our period. Our period is always 2 pi divided by our B value, and this time our B value is 3. So we get a period of 2 pi over 3. So you go somewhere on your x-axis, draw a line, and label 2 pi over 3. Then we need to divide that into 4 equal sections. So we need to cut it in half, and then cut each of those sections in half. When labeling those sections, it's going to always be easiest to label the middle one first, because you just take the 2 pi over 3 and cut it in half. Half of 2 pi over 3 is pi over 3. Then half of pi over 3, right? You can think about multiplying by half. That would just multiply that denominator by 2 and give us pi over 6. And if this is pi over 6, then the third one has to be 3 pi over 6. Maybe in your head you reduce it already, maybe you don't. You could write 3 pi over 6. But I recognize that 3 pi over 6 reduced nicely to pi over 2, so I wrote it as pi over 2 right away. So of the DAB part, the B value is the most involved, right? The D is super easy. That's your center line. Amplitude, super easy, just have to label max and min. The B value, you have to use your formula that period is 2 pi divided by your B value. And then you have to divide it into 4 equal sections. Next, we're going to draw our graph without the phase shift. Now, interesting in this one is that we have a negative out front. So if we had a regular sine graph, I would say a regular sine graph starts in the middle, going up. But this negative is a vertical reflection. A flip vertically. And if I took a sine graph and flipped it vertically, can you see it would still start in the middle, but it would be going down instead of up to begin with. So that's what I do. I go to my center line. That's my starting point. And if I'm going down, I will go to a minimum at my next ticking mark. Then back to my center line. Then at pi over 2, I would be at a maximum. And then at 2 pi over 3, back to my center line. Draw this with a dotted line. Because this is not our final graph. This is what the graph would look like if there was no phase shift. So on DAB C, that's doing the dash. And finally, what is our phase shift? It is pi over 6 to the left. So I'm going to have to go on here, and I would notice that pi over 6 to the left isn't labeled, so I would go here. Notice the distance would be the same as pi over 6. I would label pi over 6 to the left. And usually, not always, but usually your shift fits somewhat nicely with the scale that you have. So in this case, the shift is pi over 6 to the left. I'll draw the final graph in purple. I take this point, shift it pi over 6 to the left. Take the bottom point, shift it pi over 6. Take each of these points and shift pi over 6 to the left. And there is our final graph. So we're ready for example 1. In part A, when they use the word predict, it's kind of like describe or explain. How do you compare these? They just want you to go through your transformations. So we'll just do a quick label of everything, and we'll label it with 2 things. We'll go back to transformations and say what it is, and then we'll use how that relates to our new shortcuts. So for example, the 1/4 right here In transformations, that would be a vertical compression. You would multiply your y value by 1/4. In our new unit, we would be able to say that that A value affects our amplitude. Our amplitude is 1/4. Next, the 3, that 3 would be a horizontal, doesn't look like an inch, a horizontal compression where you would multiply x by 1/3. In our new unit, we know that our B value affects our period, and our period would be 2 pi divided by 3. I'll do the translations in green. That'll be a horizontal translation. I take a quick look. Notice it's already in factored form, so I didn't have to change anything. That'll just be a horizontal translation, pi over 6 to the left. Sometimes in sinusoidals we call it a phase shift. I wouldn't bother writing anything extra for that. Because basically the C value, translating it left and right, is exactly the same in transformations as in sinusoidal graphs. And finally, in translations, we would say there's been a vertical translation to up, and in our shortcut, we now know that the center line, or the sinusoidal axis, is at y equals 2. I'm going to write out dab C. And again, I did a little bit of cheating. I looked at my D and my A value to figure out what kind of scale I kind of wanted. Notice I spaced things out quite a bit because my A value, check off D. We did our D value. All we had to do is draw our sinusoidal axis. Our A value is 1/4, which is 0.25. Can you see that if you went up 1/4, you would have a maximum at 2.25, down 1/4, a minimum at 1.75. It's really squished. So I thought about my scale ahead of time. I knew it was going to be really squished, so I tried to spread things out early. But now our amplitude is done. Our B value, we already said, that makes our period. Our period is 2 pi over 3. I'm going to go somewhere on my x-axis and label 2 pi over 3. And I'm going to divide it into 4 equal sections. So cut in half, each of those sections, be pi over 3, pi over 6, and 3 pi over 6, which is pi over 2. Our B value is done. Now we draw the dash. This is a cos graph. It is a positive cos graph. A positive cos graph normally starts at a maximum. So I go to my maximum. That's my starting point. First ticking mark, I be back at the center line. Then, next ticking mark at the minimum. Next ticking mark back at the center line. And finally, back to the maximum again. There is our graph without a shift. So I can check off the dash. And finally, we need to go pi over 6 to the left. So again, very similar to the last question. I know what distance pi over 6 is. So take out my purple pen. I'm going to shift this point over pi over 6, this one over pi over 6. Everyone is getting shifted back pi over 6. And typically on the exam or on my tests, I will say to graph for at least one period and you would be done, okay? The textbook here, and we're gonna do it, it's annoying, but we'll do it anyways. The textbook said graph it from negative 2 pi to 2 pi. This is a little bit annoying because we already graphed it, and then we read that and we're like, oh, I would have to keep going in both directions and I don't have enough space. So then you would have to redraw it. So I'm going to show you what redrawing it would look like. And then I'll give you permission, if they come up like this on your homework, to change this, stroke it out and write and if you always want to draw just at least one period, that would be fine. In fact, as a strategy, I would get you to start with gap C like we did and draw that first. Then, if we want to graph it from negative 2 pi to 2 pi, what I'm going to do is I'm going to set up my scale. And on my scale, I'm going to put 2 pi over here, and I'm going to put negative 2 pi over there. My center line is still at y equals 2. My maximum is still at 2.25, and my minimum at 1.75. And what I'm going to do is I'm first going to transfer the graph that we did above onto this graph. Now, when we did the graph above, the period was 2 pi over 3. So we first of all have to figure out where 2 pi over 3 will be on this graph. Well, if this is 2 pi over 3 is taking this length and dividing it into thirds. So 2 pi over 3 would be about there. And then this got divided into 4 equal sections, which we labeled as pi over 6, pi over 3, and pi over 2. And I'm going to put a little orange line there, because technically that was one period. If I did that again, that would get me to 4 pi over 3. And I'd have to split this into 4 equal sections. And then this into 4 equal sections. So same thing on this side, I'm going to have to figure out where negative 2 pi over 3 is, and negative 4 pi over 3. And divide each of these into 4 equal sections, again with that. I'm putting orange dots on there because that length between those orange dots is one period at 2 pi over 3. Then what we had written down and what we had discovered for our purple graph is that at negative pi over 6, we're at the maximum. So at negative pi over 6, which was right here, we were at the maximum. And then we had been at the center line, then the minimum, then back at the center line, and then back at the maximum. This is what we had drawn above. Can you see now? It's just a tiny part of it. This part there is what we drew above. It just got sort of squished because they want us to graph between negative 2 pi and 2 pi. And it's just extra annoying because we just have to continue, and each ticky mark, so we were at pi over 2, now I'm there, this is now minimum, now back to middle. It's just hard to, there, middle. Which dot was I on? See why it's annoying? It's like, which dot was I on? I was there. Oh my goodness. This one is this one, this one is this one. Okay. And one of the things I can do as a sort of a check is that at those orange sections that I labeled, I should be in the middle going down. So again, I have to go backwards now and still do the same thing. Maximum, center line, label my middles. And technically I shouldn't put arrowheads on the end because they said to graph from negative 2 pi to 2 pi and stop. So this would be the final graph. It just is annoying to take extra time, but it's sometimes nice to see that what we've done is we've taken one period, which was 2 pi, and we squished it, right? Can you see how it got really horizontally compressed by that 1/3? We can really see that if we recognize that our normal coast graph would have looked like this. Normal coast graph starts at a maximum, center line, minimum, center line, maximum. This is our normal cosine graph with an amplitude of 1. Our new graph got compressed vertically. That's why its amplitude is so small. It got compressed horizontally. That's why there's so many periods now between 0 and 2 pi. And it got shifted up and over as well. Okay, questions for practice? Please circle 4, 5, 6. No, that's the next one. Please circle 3, 8, 9, 10, and 11. And I'll give you a hint. I don't think 11 is in factored form, so just be careful with that.